While this would make a great video, this is not the transformer that we will be talking about today. We're going to talk about electrical transformers and how we use them at HVAC work. There's basically two different transformers that we use in HVAC. The first one is a step-up transformer, which steps voltage from a lower voltage to a higher voltage. In this example, we have 110, 120 volts on our primary side, and we're stepping it up to 220, 240 volts on the secondary side. The second one is the step-down transformer. In this example, we are stepping 220 volts to 240 volts down to our 110 and 120 volts on our secondary side. There are a variety of different transformers that are used in transferring power from one place to another. They vary in size from transformers bigger than houses to transformers that you can hold in your hand. The most common that you see on a daily basis are those transformers on the telephone poles outside your house along the road. So the application is from the power plant. They usually step up the voltage that is produced at a power plant to be transmitted along the transmission lines, and then once it reaches its destination, they step it down to supply it to the homes. Another thing that is very important to understand about a transformer in HVAC work is the VA rating of the transformer. This is the volt amps rating of the transformer. It is the power rating for the transformer and is the voltage that it can handle when you put a load on this transformer. What we can use the 75 VA rating for is to determine what the amp load is that this transformer can handle in a circuit. By using Ohm's law, which you should have heard of by now, we've actually done a video on it. By using Ohm's law, we can determine how many amps we can apply to this transformer and still be safe to operate. By taking our volt amps, which is the 75 VA rating, and dividing it by our secondary voltage, which is 24 volts AC, we find that this transformer can handle 3 amps of additional load on it to operate successfully. In the previous slide, we found how many amps we can work with on a 75 VA transformer. In this question, which was recently seen on the NATE certification test, we can go the other way. If we know how many amps the circuit is drawing, we can determine what size transformer we're going to need to handle that circuit. The question states, a transformer with a 24 volt secondary repeatedly fails. The technician determines the load in the secondary circuit to be 2 amps. Which of the following is the smallest acceptable transformer that should be used as a replacement? By multiplying our volts times our amps, which is Ohm's law, we find that we need at least a 48 VA transformer. So most of your 40 VA transformers found in most common furnaces would not be able to handle this extra load. So we would need to get at least a 50 VA transformer to handle this circuit of 2 amps. This is the most common type of transformer that is found in HVAC work. This is a multi-tap transformer, which, depending on which wires we connect together, we can get 120 volts, 208 volts, or 240 volts on our primary side with a 24 volt secondary. So in a lot of our HVAC application, we have 240 volts that is applied to a transformer on the primary side, and then we have 24 volts on the secondary side, which does all of our control on our relays. Another thing that you want to be aware of when having 2 transformers in a system is they need to be properly phased so they don't blow the fuse or blow one of the transformers. The reason for having 2 transformers sometimes is to increase the VA rating of the system, or in some particular applications, you may have a transformer in the indoor unit and both the outdoor unit. In order to do this, you need to make sure that the transformers are properly phased together. To make sure your transformers are properly phased together, you will need your voltmeter to check the voltage coming out of the secondary side of the transformer. So take two of the leads coming off the secondary and tie them together, and then with the other two leads that are open, you will put your voltmeter across them. Apply voltage to the transformer, and then if the voltmeter reads 0 volts, the connection is correct. Remove the meter and connect the two secondary leads. However, if the voltmeter reads double the rated voltage, reverse the secondary leads. You should now read 0 voltage. You can remove the meter and connect the two secondary leads, and your transformers will be properly phased.
Go to arefco.com for more videos. Like, subscribe, and check back every week for new videos.